So students, now we are going to learn differentiation. Let us have a good grip of the chapter differentiation. This is chapter 9 of class 11th mathematics, paper 1B. Okay. If we have a grip on this differentiation, understand the concepts, so it will be useful for us in future integration, application of differentiations, application of integration, engineering, and all other subsequent problems. It's a very important topic. Let us learn it from the fundamentals. Okay. This is class 11, 1B, chapter 9. See, there is a line here. What is the slope of this line? The slope of this line is delta y by delta x, or y2 minus y1 by x2 minus x1. Wherever slope is constant, we can simply say delta y by delta x. But whenever slope is varying, see this curve slope is varying. Here slope is different. Here is a negative slope. Here is a positive slope. Here is a horizontal line, which is 0. Slope is 0 parallel to x-axis. It's because there is no change in y with respect to change in x at this point. So if the slope is continuously changing, then we calculate the slope at a particular point, at a point A, or at a point B, at a point C. What is the slope? So for that, we have come to an approach that delta y by delta x, as delta x tends to 0. Suppose this is A is there. You take a delta x. Delta x may be 0.0001. So A plus 0.0001. So if I get another y, so if I f of A plus 0.001 minus f of A, I am getting delta y. This is what f of A plus h minus f of A. I am getting delta y. By what is delta x here? This is h. A plus h means A plus h minus A is h. So delta y by delta x, as delta x tends to 0. That means we are finding a slope at this particular point of the curve. So this delta x tends to 0, this becomes dy by dx. There is a difference between delta y by delta x and dy by dx. Whenever delta y by delta x, as delta x tends to 0, becomes differentiation. If delta x is having some number, say a plus 5, h is 5. So over this point, what is the change in the value? Y2 minus y1 by x2 minus x is the average change of this. So this is delta y is average change. Delta x is average distance. So, but if delta x tends to 0, that means I am finding slope at this point. Again, at x. So this is f of x. This f of x means what? Y. F of x means what? Y arrow. For various values of x, I am plotting y here. Let this is a sine, some 10 plus sine theta. So 10 is here initial, plus it's going as a sine curve. Okay. So then this is defined as differentiation. So fundamentals of differentiation is what? F of a plus h minus f of a by h, as h tends to 0. Or we can say a plus h if I represent as x. A plus h if I represent as x. F of x. So x is very near to the point A. Let us say this is x. This point is x, or it can be this point also, in the neighborhood of A. So f of x minus f of A by x minus A. X minus A is as tends to, as x tends to A. That means x minus A is 0. That means h is 0. So these two appears different, but they are same. In place of a plus h, I am taking as x. So as h tends to 0 means x minus a tends to 0, or a minus x tends to 0. So this is the first principle of derivative. Let us see some example. Suppose fx is x square. I have a curve here, x square. It's going like this, x square. When x is 1, y is 1. X is 2, y is 4. X is 3, y is 9. There is an x square curve. So what is the slope of this curve with respect to x? So f dash x is defined. I'm taking x plus h minus x by x by h as h tends to 0. So x plus h whole square, f of x plus h means x plus h whole square minus x square by h. So when I expand this and remove x square, what I am getting? H into 2x plus h by h. So h getting cancelled. So answer is 2x. So that means what? F dash x is 2 into x. 2 into x. So you see, we know this d by dx of x of n is n into x to the power of n minus 1. That means 2 into x to the power of 2 minus 1 is 1. So 2x. So this is a formula. We have converted this type of approach into a formula. And that formula, this is from fundamentals, this is from the formula. That means what? What do you mean by 2x? What is this d by ds of x square is 2x? That means at x is 1, the slope is 2. When x is 4, the slope is 8. When x is 10, the slope is 20. That means y is changing 20 times than x at that point. Here y is equal to changing x and y equal. 2x is 2 times. So like that, the slope is varying. The slope is what? The rate of rise is varying. The rate of y is varying with respect to x. That is what we mean by 2x. X square is the curve, 2x is the slope variation with respect to x. Okay. Now let us see root x. Root x means what? X to the power of half. So again, root of x plus h minus root of x by h as h tends to 0. So we know the binomial expansion. X to the power of half plus half into x to the power of half minus 1 into h plus half into half minus 1 by 2 n. Suppose let us this is n. X to the power of n plus nc1 into x to the power of n minus 1 into h to the power of 1 plus nc2. This is nc2 into x to the power of n minus 2 into h to the power of 2. Like that it is expansion. So x to the power 1 by 2 and x to the power 1 by 2 getting cancelled. So if I take out h here, out, this h, I am taking out outside. So this h and h getting cancelled because everywhere h square, this h square, this h cube. So h will go out. So when I substitute h as 0, so all these terms will become 0. From this onwards, terms will become 0 because this h is getting cancelled. So what is left out? Half into x to the power of minus half. X to the power of minus half is 1 by 2 root x. 1 by 2 root x. That is why differentiation of root x is 1 by 2 root x. Or if we use this formula, n is half. So half into x to the power of n minus 1. So this is minus half. So 1 by 2 root x. Either through formula or through fundamentals, we should know this expansion, binomial expansion. Okay. Now, let us see another one. Fx is 1 by x square plus 1. What is f dash x? Again, I put in place of x, I put x plus h whole square. So 1 by x plus h whole square plus 1 minus 1 by x square plus 1 by h. In place of x, I am putting x plus h. This is f of x plus h. This is f of x. So when I take my LCM, x square plus 1 into x plus h whole square plus 1, this is my LCM. H is already there in the denominator. So in the top, what is numerator? I'm getting x square plus 1 minus of x square plus h square plus 2xh plus 1. So I'm all are minus. So this is getting cancelled, x square getting cancelled, 1 and 1 getting cancelled. What I am getting here? If I take h common out, and h is h getting cancelled out. Getting, now I put minus 2x by h into this. So when I substitute h is 0, this becomes 0, h is 0. So minus 2x by x square plus 1 into x plus 1 into x square plus 1. That means x square plus 1 whole square. Square plus 1 whole square. So minus 2x by x square plus 1 whole square. This we know. Suppose now we have used to the power of n. What is this? X square plus 1 whole to the power of minus 1. So minus 1 into x square plus 1 whole to the power of minus 1 becomes minus 2 into what is x square differentiation? 2x. So that's what I'm getting, minus 2x by x square plus 1 whole square. This is through formula and this is through my fundamental approach. What I am fundamentally doing, I am removing this x square and 1, x square and 1. They are getting deleted. And rest everything is multiplication of h. So one h I take out. This h and h getting cancelled. So what was first term without h is my answer. So minus 2x by x square plus 1 whole square. It is like that. Minus 1 by u square into du. If it is 1 by u, the differentiation is minus 1 by u square into du. So minus 1 by x square plus 1 whole square into what is du? Du is 2x. We have just seen x square differentiation is 2x. So 2x. So minus 2x by x square plus 1 whole square is nothing but u to the power of minus 1. So minus 1 into u to the power of minus 2. So this is what I am getting. Okay. So let us see some differentiation of elementary. F of x is sin x, and what is different slope of sin x? So again, go for fundamentals. Sin x plus h minus sin x by h as h tends to 0. That means I am varying sin x a small value as h tends to 0. So this we know, sin a cos b plus cos a sin b minus sin x by h. Okay. As h tends to 0, what is cos h? Cos h becomes cos 0. Cos 0 is 1. So then if I take, so I am applying this, when this is 0, so this portion is becoming 0. Cos h is 1. This is becoming sin x to sin h. So sin x into 1 plus cos x sin h minus sin x. This sin x and this sin x getting cancel. Sin x and sin x getting cancel. So we got here cos x into sin h by h. Limit of sin h by h as h tends to 0. So this is sin h by h. We have seen earlier limits and continuity. This is 1 because as h tends to 0, sin h becomes h itself. So h and h getting cancelled. So answer is cos x. That is why we know differentiation of sin x is cos x and differentiation of cos x is minus sin x. Because cos of x plus h is cos a cos b minus sin a sin. So minus sin x is the further cos x differentiation. Now, note that mod x is not differential at x is 0 because at x is 0 plus and x is 0 minus, the values are different. So this is not defined. Suppose for a constant, fx is constant. Constant means what? What do you mean by constant? F of x, where whatever x is varying, but y is constant. This is a line. It's a parallel line to x axis. That means the slope is automatically 0. So f of x plus h minus f of x by h. F of x plus h is also k. This is also k. K minus k 0. 0 by anything is 0. So the slope is 0. Now, if formula is given, if f of x plus y is equal to f of x into f of y, then f dash 0, if 0 exists, then f dash x is equal to f of x into f dash 0. This is the given condition. These three are given. F of x plus y is f of x into f of y. And also f dash 0 exists. Let us see here. F of f dash x. How f of f dash x is defined? F of x plus h minus f of x by h as h tends to 0. But it is given f of x plus y is equal to f of x into f of y. So f of x plus h is equal to f of x into f of h. So if I take out f of h outside, this f of h minus 1 by h as h tends to 0. This is nothing but f dash h. Nothing but f dash h. So f of x into f of h minus 1 by h as h tends to 0 is f of x into f dash h. F dash 0 rather. Let us see here. F of 0 can be written as f of 0 plus 0. Because if I substitute x 0 many times, no problem. So this is nothing but f of 0 into f of 0 from this given expression. So that means if I take f of 0 common, f of 0 into 1 minus f of 0 is equal to 0. That means either f of 0 is 0 or 1. If f of 0 is 1, 0, that means automatically here my f of x is equal to f of x plus 0. F of x into f of 0, that means f dash x is also 0. So f of x plus y is f of x into f of y. F of x into f of 0. F of 0 is 0. So that means automatically f of x plus 0 is 0. So f dash x is also 0. But f dash if it is 1, then f of 0, if it is 1, f dash x is f of x into this portion. F of h minus f of 0, because f of 0 is 1, we have seen here. F of h minus 1, I replace as f of 0. F of h minus f of 0 by h, as h tends to 0, is nothing but f dash 0. So this is what proved. F dash x is f of x into f dash 0. So this is possible if f of 0 is 1. F of 0 is 0, is automatically 0. So this is just complicated some derivation. We need not go through it now. Once we get acquainted with the differential functions, we can come back to this for a revision. We need not just have an understanding, but we can move on. Let us see some properties. If xs is differentiable at a, it is continuous at a. Differential means what? What is f dash x? F dash a. F of x minus f of a by x minus a as x tends to a. That means f of x minus f of a is equal to x minus a into f dash a. As x tends to a, this is 0. Because x minus a is 0, so this becomes 0. That means f of x is equal to f of a. That means it is continuous. Either it is x plus or x minus, it is f of a. But reverse may not be true. If it is continuous, need not be differentiable. Suppose mod x is there. What is mod x we have just seen? It is not having a differentiation. 0 plus is plus 1, 0 minus is minus 1. It has different slopes. It has different slopes. So this is not continuous. If you see the mod x, I'm just drawing here. Where I can draw, suppose I draw here. This is x-axis, y-axis, and this is x-axis. What is mod x? Mod x means irrespective of x minus, y is plus. Okay. Again, same. Irrespective of x plus, y is plus. So this is mod x. So at every point you have f dash x. Here what is slope? This is the slope. Here negative slope. Here positive slope. But at 0, f dash x is showing both negative and positive slopes. So f dash x does not exist for f of x is mod x. So even though this is a continuous line, you see, there is no discontinuity. It is a continuous line, but the differentiation is not available here. So what these two are telling, if it is differentiable, then f of x is continuous at a. If it is continuous, it need not be differentiable. Okay. Right. Now, let us see. F dash u plus v. So it is a u of x plus h plus v of x plus h minus v of x minus v of x by h. Nothing but u dash x plus v dash x. So if two functions are there with a plus, I can do separately, I can do differentiation. I need not complicate them adding together. I can do differentiation separately. Because u plus v, you say u is x square, v is x cube. So f dash of x square plus x cube is equal to 2x plus 3x square. Like that. Okay. Now f dash u into v. So u into x plus h into v into x plus h minus u into x, v into x by h. This is from the fundamentals. I am finding a value at plus h and minus from value at x. So difference by h as h tends to 0. So if I add and subtract u into x plus h into vx plus vx into u into x plus h, see, this is subtracted, same thing is added. So when I rearrange the terms, I get u into x plus h into v, this is v dash, v x into this is u dash. So u v dash plus v u dash is my multiplication. U v dash plus v u dash. So how we differentiate a multiplication function? First I assume u as constant, u into v dash plus then next time I am assuming v as constant, v into u dash. Like that it should be differentiated. Same thing for extending for 3 u v z. U dash v z, v dash u z, z dash u v. So again u to the power of nx, n into u to the power of n minus 1x into du, u dash x. So 1 by u dash x. 1 by u dash x. Let us see here. 1 by f of x. 1 by f of x is equal to 1 by f of x plus h minus 1 by f of x by h as h tends to 0. So f of x minus f of x plus h by h into f of x into f of x plus h. So this is nothing but minus f dash f of x plus h minus f of x by h is minus f dash x, and this is when I put h is 0, f of x into f of x square. So this is nothing but minus f dash x by f of x square. This is what we have seen here. This is minus du by u square, minus du by u square. Same way. So this is the derivation. So minus f dash x by f dash x, fx whole square, minus u dash x by ux whole square. So here is an example, x square. So x square, 1 by f is 1 by x square, u dash is minus 2 into x to the power of minus 3 into 2x. So minus 2 into x minus 3 into 2x. This is du, this is u dash x. Fx is x square, 1 by x square I am differentiating. So minus 2x by x cubed. So minus 2 by x square. By x to the power of 4 it has come here. Minus 2 into x to the power of minus 3. Simple. So minus 2 by x cubed. Okay. X to the power of minus 2. X to the power of minus 2 is minus 2 into x to the power of minus 3. So minus 2 by x cubed is the answer. Otherwise, if you do for u dash x, minus 2 into x, this is u dash x. Otherwise, du by x square. So 1 by x square whole square is x to the power of 4. Du is 2 minus 2x. So x and x getting cancelled. So minus 2x. Either through this formula or to the power of minus, both can be done. So it is minus f dash x by fx whole square when you differentiate 1 by f of x. So similarly, if I apply with u by v dash x, so u into 1 by v dash x plus 1 by v into u dash x. So what is v dash x? 1 by v dash x is nothing but 1 by v square by v dash minus v dash by 1 by v square. So if I am taking out 1 by v square out, so u dash x into vx, because there is only one v. 1 by v is there, I am putting 1 by v square, so vx minus ux into v dash x. So this is the formula. 1 by vx whole square into u dash x vx minus ux v dash x. So otherwise, if you don't write 1 by vx whole square, how we can write is 1 by v into u dash x, 1 by v, because first term I am keeping constant, second term, first term I am differentiating, plus ux into 1 by vx1, that is issue, u dash, plus ux into, what is the differentiation of 1 by vx is equal to minus v dash x by vx whole square. So this is the differentiation. So I am taking vx whole square out, and taking vx whole square out is I am getting vx u dash x minus, this minus is there, minus into plus minus, minus ux v dash x. So this is the formula, and this is the UV method. Both are okay. F of gx is equal to f dash gx into g dash x. It is like this. Z of fi, dz by dx is equal to dz by dy into dy by dx. Here dy getting cancelled. I am getting dz by dx. This simple mathematical cancellation also applicable in dy by dx. I can take many times. Suppose I can go it as dz by dt into dt by dy into dy by dp into dp by dx is equal to dz by dx. Because dt getting cancelled, dy getting cancelled, dp getting cancelled, dx. Simple mathematical. So I can go ahead with differentiation of making it easy. So now let's understand derivation of an inverse function. Suppose sine inverse x, cos inverse x, tan inverse x, like an inverse function is nothing but 1 by differentiation of direct function. Let us say d by dx of sine inverse x. It is nothing but 1 by d by dx of sine x. 1 by d by dx of sine x is 1 by cos x. What is cos x? Cos x is 1 minus, when sine inverse x is, let us say, y, then sine y is x. So cos x is root of 1 minus x square. Okay. Now how we got it? The philosophy is 1 by sin x differentiation. It is 1 by cos x. So what is cos x? Suppose if sin inverse x is y, if I put sin inverse x is y, then inverse comes to this side, sin y is equal to x. What is cos y? Cos y is square root of 1 minus x square. Cos y is square root of 1 minus x square. So y is equal to cos inverse square root of 1 minus x square. Sin inverse x is equal to y. If I take sin this side, sin y is equal to x. So if I'm differentiating, cos y dy is equal to dx. So dy by dx is equal to 1 by cos y. When sin y is x, what is cos y? 1 by square root of 1 minus x square. So dy by dx means, what is dy by dx? dy by dx of sin inverse x. What is y means? Y is sin inverse x. So the inverse function is 1 by dy by dx of direct function. So suppose for tan inverse x, d by dx of tan inverse x. So 1 by d by dx of tan x. That means 1 by secant square x. 1 by secant square x means 1 by 1 plus x square. Because tan x is y, tan y is x, secant square y is 1 plus x square. 1 plus tan square. Same way. So this is how the inverse functions are derived. So before going to chapters, let us have fundamental series revision. We know what is sin x, x minus x cubed by 3 factorial, x or 5 by 5 factorial, x or 7 by 7 factorial, like that. What is cos x? 1 minus x square by 2 factorial, x or 4 by 4 factorial, x or 6 by 6 factorial, like that. What is e to the power of x? 1 plus x by 1 factorial, x square by 2 factorial, x cubed by 3 factorial. What is log of x plus 1? X minus x square by 2 plus x cubed by 3 minus x cubed by 4 plus x by 5 by 5. These are the fundamental expansion series. Suppose when I differentiate this sin x, I am differentiating sin x. What I am getting? X differentiation is 1, x cubed is 3x square. 3 getting cancelled. So x square by 2 factorial. So this is 5x to the power of 4. 5 getting cancelled. X to the power of 4 by 4 factorial. So the differentiation of sin x is cos x. Again, I differentiate cos x. This becomes 0 minus 2x by 2 factorial. 2x by 2. So minus x by 1. This is plus 4x cubed by 4. 4 factorial getting cancelled. X cubed by 3 factorial. This is plus. This is plus. So if I take total minus out, so this was plus minus x plus x minus x cubed by 3 factorial plus x of 5 factorial, like that. It comes to minus sin x. Here itself. So e to the power of x I am differentiating. So x of 0, 1, 1 becomes 0, x of 1 becomes 1. This is 2x, 2 getting cancelled, x by 1 factorial, 3x square, 3 getting cancelled, x square by 2 factorial. So it is getting repeat. This term is becoming second term is becoming first term is becoming first 0. So e to the power of x, when I differentiate, it remains as e to the power of x. So we should be able to understand. These are the fundamentals, expansions. So let us continue differentiation. We'll see some textbook problems and we'll solve them. We'll understand through the problem solving. Okay, let us see this problem. Log of x. We want to differentiate log of x. So log of x can be divided f of x plus h minus f of x by h as h tends to 0. This is dy, this is dx. So let us say log of x plus h minus log of x by h as h tends to 0. We know log a minus log b is equal to log a by b. So x plus h by x is equal to 1 plus h by x as h tends to 0. We know just we have seen what is log x is defined as log x plus 1, x minus x square by 2 plus x cubed by 3 minus x to the power of 4, like that. So in place of x, it is x h by x. So this is this is h by x minus h square by x square plus x cubed by x cubed, like that. So if I take out h here, so 1 by x is left out here. H is getting cancelled. So wherever h I put 0, all the terms are becoming 0. Answer is 1 by x. That is why differentiation of log x is 1 by x. or we can do it in another form. Log of 1 plus h by x by h. This is the form we got. So this can be written as 1 by h into h by x log of 1 plus h by x whole to the power of x by h. Whole to the power of x by h. Suppose this whole to the power of x by h, I bring it here. So x by h into log of 1 plus h by x. X by h, h by h getting cancelled. So original term remaining. So this we know log of 1 plus x whole to the power of 1 by x. Log of 1 plus x whole to the power of 1 by x as x tends to 0 is 1. So answer is h is getting cancelled, 1 by x is remaining. This is the limit. This is the limit form we have seen, log of 1 plus x whole to the power of 1 by x. And this is the expansive form. Both way, differentiation of log x is 1 by x. Similarly, differentiation of eighth order of x from first principle. So eighth order of x can be written as eighth order of x plus h minus eighth order of x by h. So if I take eighth order of x out, eighth order of h minus 1 by h as h tends to 0. So we know this is a logarithm of this eighth order of x log a. This is log e, this is log a. This we have seen in limits and continuity. Eighth order of x minus 1 by x as x tends to 0 is log a. Similarly, e to the power of x minus 1 by x as x tends to 0 is log e that is 1. So this is nothing but 1. So e to the power of x log a is the answer. So differentiation of e to the power of x is e to the power of x itself. Differentiation of e to the power of x is e to the power of x log a. You've seen here is e to the power of x. If I differentiate, I'll get the same term. Second term will become first term. Third term will become second term. Because 2 getting cancelled, x by 1 factorial. 3 getting cancelled, x square by 2 factorial. So like that, e to the power of x differentiation is e to the power of x itself. Similarly, e to the power of x differentiation is e to the power of x log a. E to the power of x log a. So we should have a revision of limits and continuity before going for differentiation. Suppose f of x is this, find f dash. This is u by v formula. So 1 by v square into v into u dash x minus u into v dash x. So simplifying it, we get the answer. Let us see this problem. Root of 1 plus x square by 1 minus x square. Again, UV problem. 1 by 2 root of 1 plus x square by 1 minus x square into 1 minus x square into 2x minus 1 plus x square into minus 2x by 1 minus x square whole square. What we have done here? Let us assume this as root x. So 1 by 2 root x into du dx. So when we are differentiating this, this is in the form of u by v. So 1 by v square, 1 minus square whole square into v into u dash x minus u into v dash x. So the whole term when I am simplifying. So how I have proceeded? 1 by 2 root x. Otherwise it can be simply said root of 1 plus x square by root of 1 minus x square. That way also u by v can be done. 1 by v square root also 1 by 1 minus x square into dv. V into du is 1 by 2 root of 1 minus x 1 plus x square into 2x. So whatever way you take it, this will come to same way. So this is the simplified answer. So 1 minus x square has come up. Root of 1 minus x square by 2 root of 1 plus x square into 2x minus 2x cubed minus 2x cubed by 1 minus square whole square. So 1 plus x square into 1 minus square is 1 minus x to the power of 4. 1 minus x to the power of 4. So this is 2x into 2x by 1 minus x square. 1 minus square, 1 minus square is getting cancelled, 1 minus square is left over. 1 plus x square, here 1 plus 1 minus x square. Here you see, here minus into minus plus. So plus 2x cubed. These two are sign are wrongly written. So 2x to 2x will get cancelled. 2x plus 2x is 4x. 4x by 2, it becomes 2x. Then root of 1 minus x square, root of 1 minus x square. Here 1 minus x square whole square. So this becomes 1 minus x square root of 1 minus x square. So 1 minus square we have taken out here. Root of 1 minus x square into root of 1 plus x square is root of 1 minus x to the power of 4. So this is a simplified version of this. Okay. A to the power of x cubed plus 3x. A to the power of x. We know a to the power of x is a to the power of x log x into du by dx. So a to the power of x, sum to the power of this into log a. Log a is 7. Log a into what is du by dx? 3x square plus 3. So we have done it 3 forms. A to the power of x log a to the power of x log a into dA by dx. Okay. So let us see here. d by dx of root of x plus 2x to the power of 3 by 4 plus 3x to the power of simple. This is 1 by 2 root x. This is x to the power of 3 by 4 into 3 by 4 minus 1. 5 by 6 into 5 by 6 minus 1. So we can simplify it. So similarly, x square minus 3 into 4 is cubed plus 1. Whether I will multiply and expand and do differentiation. 5 fours are 20x to the power of 4. 2x minus 36x square 0. Or we can do UV formula. U into V dash plus V into U dash. Then also we get same answer. So here d by dx of 5 to the power of x plus log x plus x cubed e to the power of x. So we have 3 functions. So this is 5 to the power of x log 5, e to the power of x log a. This is 1 by x. This is 3x square e to the power of x plus x cubed e to the power of x. UV formula. So by acquainting more and more, we should be able to do it. This is a by b form. So 1 by v square into v into 2px plus q minus u into a. So simplifying, rearranging. So d by dx of log x base 7. Log x base 7 is a typical. Let it be y. So 7 to the power of y is equal to log x. So when I do differentiation, 1 by x dx is equal to 7 to the power of y log y dy. 1 by x dx is equal to 7 to the power of y log y dy. Log 7. A to the power of x log a. So 7 to the power of y log a dy. So dy by dx is equal to 1 by x into log 7 into 7 to the power of. So we know y is 7. Y is log x base 7. So here dy by dx is equal to 1 by x, this whole thing coming to bottom. Log 7 is coming to bottom. 7 to the power of y also coming to bottom. So 1 by x into 1 by log 7 becomes log e to base 7 when it comes to numerator. Here 7 to the power of y in the denominator comes to numerator as minus 7 to the power of minus minus y log 7. What is y? Y is log x. So minus log 7 log x. 7 to the power of. So this is nothing 1 by x log e to 7 into 1 by log. This is nothing but 1 by log x. See how this has become? 7 to the power of minus log of log x. At y is equal to log of log x. What is y? We got 7 to the power of minus y. Y is log of log x to base 7. This whole thing is y. So 7 to the power of minus log of log x. Let it be z. Then it is that is what log z to base 7 is equal to minus log x to base 7. That means z is equal to minus log x. Z is equal to minus log x. That is 1 by log x. By log x. Seven to the power of minus of log x is z. So 7 comes to here. Log z to base 7 is equal to minus log of log x. This minus go log x to the power of minus 1. That means 1 by log x. So log of 1 by log x. That means z is equal to 1 by log x. Z is equal to 1 by log x. That is what it has become here. Log e to base 7 by x log x. Okay. So we should have a knowledge of logarithmic changeovers with 1/8 of x log x and log x. This both we should have knowledge. Now, this is simple. 8 to the power of x into e to the power of x square. So first, e to the power of x square I am keeping constant. E to the power of x log a differentiation. So then e to the power of x into e to the power of x square into 2x. Simple. Okay. F of x is this. Find f of 1. Find f dash 1, not f of 1. Find slope at 1, f dash 1. So what is f dash x? 1 plus 2x plus 3x square plus 100 into 19, x to the power of 19. So if I put 1, it is a sum of first 100 terms. So 100 into 100, 1 by 2. Let us see. Execute from first principles. Exercise 9a. So x plus h whole cubed minus x cubed by h as h tends to 0. So a cubed plus b cubed plus 3ab square b plus 3ab square. So here x cubed getting cancelled. I can take out h from here. H and h getting cancelled. So what is left out? 3x square is left out. When I put h is 0. So x to the power of n is n into x to the power of n minus 1. So 3x. So x plus 1 root from fundamentals. X plus 1 plus h whole to the power 1 by 2 minus x plus 1 whole to the power 1 by 2 by h. This we have binomial expansion. And these two getting cancelled. So when I take out h, what is left out? 1 by 2 root x plus 1. 1 by 2 root x plus 1. This is with the fundamental principle. So sine 2x. So we have done sine x, now sine 2 into x plus h minus sine 2x by h. This is what? This is sine a minus sine b. Sine a minus sine b is 2 cos a plus b by 2 into sine a minus b by 2. We know this formula. So when I put here sine h by h, limit of h tends to 0 is 1. So 2 cos x, 2x plus h. When h is 0, it is 2 cos 2x. So differentiation of sine 2x is cos 2x into 2. So 2 cos 2x. This is from fundamentals. So all that way we can prove fundamentals. Let us see dy dx of secant 3x. Secant 3x plus 3h minus secant 3x by h as tends to 0. So this is 1 by cos 3x. This is 1 by cos 3x. So cos 3x minus cos 3x plus 3h by h into secant 3 cos 3x into cos 3x plus h as it tends to 0. Now this we know cos a minus cos b minus 2 sin a plus b by 2 into a minus b by 2 sin a minus b by 2 minus 2 sin a plus b by 2 into sin a minus b by 2. So again, so 2 sin 3x by cos 3x by cos 3x into sine 3h by 2 by sine 3h by 2 into 3 by 2. See, here we got sine 3h by 2. This minus into minus plus sine 3h by 2. So h I have written as 3h by 2 into 3 by 2. So I have divided by 3 by 2, multiplied by 3 by 2. So that this limit as h tends to 0 becoming 1. This is 3 by 2 and cos 3x is getting cancelled. So 2 into 2 getting cancelled, 3 tan 3x. This is tan 3x, this is secant 3x. 1 by cos 3x is secant 3x. So cos 3x into cos 3x, because h is 0, this also become cos 3x. So cos 3x square. It is converted to two terms. One is sin 3x by cos 3x is tan 3x. 1 by cos 3x is secant 3x. So this is nothing but secant x differentiation is secant x tan x into 3. So secant x tan x into 3. This is from fundamentals. So dy dx of cos square x. So cos square x plus h minus cos square x by h. This is a plus b into a minus b. So we know cos a plus cos b is, this is cos a minus cos b. Or we are expanding this. Cos a cos b minus sin a sin b. Cos x cos h minus sin x sin h. This is cos x cos h plus sin x sin h. This is also minus sin h sin x. So all these things I am taking cos x out. So cos x plus cos h, cos x plus cos h into cos x. So here, if I put h is 0, this becomes cos x. Cos x plus cos x is 2 cos x. So 2 cos x into cos x cos h minus sin x sin h minus cos x by h. So here, when cos h is 0, h is 0, this is 1. So cos x minus cos x getting cancelled. So this becomes my 2 cos x minus sin x sin h by h. So we know sin h by h, limit of h tends to 0 is 1. So minus 2 cos x sin x. That means minus sin 2x. Minus sin 2x. Otherwise, what is cos square x? Cos square x is 1 minus cos 2x minus 1, 1 minus cos 2x by 2. So 1 minus 2 sin square is 2 gets cancelled. So 1 minus cos 2x by 2. When I differentiate, cos 2x is minus sin 2x into 2. 2 getting cancelled. So minus sin 2x I am getting. This is from direct transmission. This is from fundamentals. Okay. Now you see here. A x to the power of 2n log x plus b x to the power of n into e to the power of minus x. It's simple. So a x to the power of 2n differentiation of log x is 1 by x. Log x into differentiation of this a into x to the power of 2n. 2n into x to the power of 2n minus 1 plus b into n into x to the power of n minus 1 e to the power of minus x plus e to the power of minus x to the power of n minus 1 x to the power of n into e to the power of x into minus 1 plus e to the power of minus x into n into x to the power of n. A simple expansion. Let us find out whether f dash to 2 exists or not for this. F of x is x for less than 2. F of x is 2 for more than 2. So f dash 2 is f dash 2 minus h minus f of 2 by minus h as h tends to 0. So 2 minus h, f of 2 is less than is h itself. So this is the left hand side limit we are first calculating. F dash 2. Limit of f of 2 minus h minus f of 2 by minus h as h tends to 0. Or because it is less than 2, so f of 2 minus f of 2 minus h by h. So minus sign is bottom, no problem. So now f of 2 minus h, if it is less than 2, it is equal to x itself. So f of 2 minus h is 2 minus h. This is minus 2. 2 getting cancelled. Minus h by minus h, that is plus 1. Similarly, for right hand side is equal to 2. So this is 2 minus 2 by h, that is 0. So these two are not same. So here limit does not exist. Limit does not exist. Let us continue the differentiation. Now we will extend it to trigonometric functions, hyperbolic, inverse, and trigonometric functions. Let us see. We know d by dx of sin x is cos x, because we have the fundamentals. Sin of x plus h minus sin x by h, as h tends to 0, will become cos x. Similarly, cos x is minus sin x, tan x is secant square x, then cosecant x is minus cosecant x cot x, secant x is secant x tan x, and cot x is minus cosecant square x. Okay. Now let us say, let us see secant x. So y is secant x. What is secant x? Is 1 by cos x. Then dy by dx is minus 1 by cos square x into what is the cos x is minus sin x. Okay. If it is a u, minus 1 by x square into dx, minus 1 by cos square x into minus sin x. So sin x by cos x is tan x. Sin x by cos x is tan x. 1 by cos x is secant x. So minus into minus plus. So this is secant x tan x. So here it is a, what is this? This is cos x to the power of minus 1. So minus 1 into cos x to the power of minus 2 into minus sin x. So this is what? Minus 1 by cos square x into minus sin x. So similarly, let us see for tan x. Tan x is sin x by cos x. So 1 by cos square x into cos x minus sin x into minus sin x. So cos square x plus sin square x is 1. So this is 1 by cos square x. That means secant square x. So similarly, we can prove for others also, either using u by v or 1 by u dy dx formula. Let us come to inverse x. Sin inverse x is 1 by square root of 1 minus x square. We have just seen here sin inverse x. Where it is that we have seen sin inverse x? Here it is. Sin inverse x. Sin inverse x is, if it say y, that sin inverse x is y, that means sin y is equal to x. That means cos y dy by dx is equal to 1. So dy by dx is 1 by cos y. Dy by dx is 1 by cos y. And sin y is x. Cos y is square root of 1 minus sin square y. So square root of 1 minus x square. So 1 by square root of 1 minus x square is dy by. What is dy by dx? D of y by dx. Y is sin inverse x. So d of sin inverse x by dx is equal to 1 by cos y. That is equal to 1 by square root of 1 minus x square. Because cos y is square root of 1 minus sin square by cos square. So this is how we have seen earlier. So sin inverse x is 1 by square root of 1 minus x square. X cannot be more than 1. Because if it is more than 1, then it goes into the non-real term minus I. Okay, inverse diagonal. Similarly, for cos inverse x is minus 1 by square root of 1 minus. So we have seen here earlier formula, derivatives of cos inverse x, 1 by derivatives of cos x. Derivatives of cos x is sin x. 1 by minus sin x. So minus 1 by sin x is root of 1 minus x square. Okay. So this is a cos inverse x. Now tan inverse x, 1 by 1 plus x square, because 1 by tan x, divide x of 1 by tan, divide x of tan x. Tan x is secant square x. Tan x is x. So secant square x is 1 plus x square. So let us see here. Let us see this derivation. Tan inverse x. Y is tan inverse x. That means tan y is equal to x. That means secant square y dy is equal to dx. Dy by dx is 1 by secant square y. Tan y is x. Secant square is 1 plus x square. 1 by 1 plus x square. Okay. Similarly, secant inverse x. Let us see secant inverse x is y. So secant y is x. So secant y tan y is equal to dy. Dy is equal to dx. Dy by dx is equal to 1 by secant y tan y. Secant y is x. Tan y is square root of x square minus 1. Square root of secant square y minus 1. So that is 1 by x root of x square minus 1. So this is what secant inverse. 1 by square root of 1 by x root of x square minus 1. Similarly, cosecant minus 1 by x root of x square minus 1. Why I have given mod x here? Because this is 1 by square root of x root of x square minus 1. This is minus 1 by square root of x square minus 1. Okay. So this is plus, this is minus. Up to 9. These are all up to pi by 2. All up to pi by 2. So let us see. Secant y is equal to x. Secant y tan y dy is equal to dx. So dy by dx is equal to 1 by secant y tan y. So we know secant y is x. Tan y is square root of secant square y minus 1. So square root of x square minus 1. Okay. Here you see mod x is greater than 1. Because if mod x is less than 1, this becomes a irrational number. So mod x is greater than 1. So these are the inverse trigonometric functions. These are the trigonometric functions. These are the derivations. Simple derivations. Simple derivations. Okay. Now, just remember here, just before going further, what is sin inverse x differentiation? 1 by square root of 1 minus x square. Suppose if it is 1 by square root of 1 plus x square, then if it is 1 by square root of 1 plus x square, then what differentiation it is? 1 by 1 plus x square is tan inverse x. 1 by square root of 1 plus x square, this is sin h inverse x, hyperbolic function. Sin, no, it is tan h inverse x. 1 by square root of 1 plus x square is tan h inverse x. Minus 1 by square root of 1 plus x square is cot h inverse x. Square root is there. Here, 1 by square root of x square minus 1. Suppose it is 1 by square root of x square minus 1. Then it is sin h inverse x. Minus 1 by square root of x square minus 1 is cos h inverse x. Here also, x root 1 minus x square, secant h inverse x. So we'll just see the relations. We'll go down, and when we see hyperbolic functions, we'll compare with that for more understanding. This is hyperbolic functions. So why sin hx? Sin hx has been defined as e to the power of x minus e to the power of minus by 2. So when I do dy by dx of sin hx, e to the power of x plus e to the power of minus x by 2, which is cos hx. So derivatives of sin hx is cos hx. If I do derivatives of cos hx, e to the power of x minus e to the power of minus x by 2, because minus x will come into minus 1. So minus e to the power of minus x by 2, which is nothing but sin hx. So here derivatives of sin hx is cos hx and derivatives of cos hx is sin hx. In sin terms, it is minus sin x. Sin x derivative is cos x. Cos x derivative is minus sin x. But in hyperbolic, there is no minus. Sin hx is cos x, cos hx sin hx. Because that is how they are defined. Hyperbolic functions are defined. Let us see tan hx. Derivatives of tan hx is secant square hx. Cot hx is minus cosecant square hx. Same. Tan x is secant square x. Cot x is minus cosecant square x. It is also same. Cosecant hyperbolic square x. Now, derivatives of secant hx is minus secant hx tan x. Derivatives of cosecant hx is minus cosecant hx cot x. Here, this minus will not be there for secant x. Secant x is secant x tan x. Cosecant x is minus cosecant x cot x. But here, in hyperbolic, this is also minus. Secant hx is equal to minus secant hx tan hx. Cosecant hx derivation is minus cosecant hx cot x. See, these are the hyperbolic functions. See, hyperbolic, this is sin hx. Sin hx. When x is 0, y is 0, sin h0 is 0. Because e to the power of x minus e to the power of minus x, x is 0, 1 minus 1 by so 0. So this is going to infinity. This is also going to infinity. This is sin hyperbolic function. This is cos hyperbolic function. At cos hx, x is 1. Cos hx, when x is 0, this is 1. Otherwise, it is increasing. You see, sin x value cannot be more than 1. Sin x value plus or minus 1. But sin hyperbolic function going to infinity. Because it is e to the power of x plus minus e to the power of minus x by 2. This is also cos hx. It is like that y is equal to x square or x is equal to y square. That formula. This is tan hx. The horizontally going. As x is increasing, y is a limiting factor. Similarly, this is cot h inverse x. Tan is going like this, cot is going opposite. They're all hyperbolic. This is secant hx. Secant hx. Where is secant hx? Let us see. This is cosecant hx. Almost cosecant and cot are similar type. This is secant hx. So these are all hyperbolic functions. These are all hyperbolic functions. Let us see how an hyperbola is defined as. This is an hyperbola function. This is hyperbola. Here, suppose you take any point on hyperbola x, y. If x square minus y square is equal to 1, that means y is sine hyperbolic t, x is cos ht. So cos square x minus sine square x is equal to 1. If you see here, what is cos h square x? Is e to the power of 2x plus e to the power of minus 2x plus 2 into plus 2 by 2 plus 1. This is what is sin h square x. E to the power of 2x plus e to the power of minus 2x minus 2 into this. So cos square x minus sin square x is, these two are getting cancelled. So 2 by 2, 1. So cos h square x minus sin h square x is 1. Is 1. So this is the point how this point is defined, hyperbolic function. These are the asymptotes. Y is equal to x and y is equal to minus x. These are the asymptotes of the hyperbolic function. Okay, let us see the inverse hyperbolic functions. Let y is equal to sin h inverse x. That means sin hy is equal to x. That means cos hy dy by dx, 1 by cos hy. 1 by cos hy is 1 by, what is the difference? How they are related? cos h square y minus sin h square y is equal to 1. So 1 plus cos h square y. So sin hy is equal to x, cos hy dy is dx. So dy by dx is 1 by cos hy. 1 by cos hy is 1 by square root of 1 plus x square. Because cos square x minus sin square x is 1. So cos hy is 1 plus sin square x, cos h square root of 1 plus sin square x. But sin hx we have just seen, sin y is x. So cos y is 1 plus sin h square y. That is 1 plus x square. So what is the derivative of sin h inverse x? 1 by square root of 1 plus x square. 1 by square root of 1 plus x square. This is what we have seen here. If it is 1 by square root of 1 plus x square, this is sin h inverse x derivation. Once I solved tan h inverse, it is not there, but 1 by square root of 1 plus x square is sin h inverse x. Minus 1 by square root of 1 plus square is cos h inverse x. Okay. Similarly, others also can be derivated. Let us see. Sin h inverse x can also be written as log of x plus square root of x square plus 1. And it is also easy, also be written as this is sin h inverse x is defined like this. Log of x plus square root of x square plus 1. The derivative is 1 by square root of 1 plus x square. Cos h is defined as log of x plus square root of x square minus 1. Or derivative of cos h inverse x is plus or minus 1 by square root of x square minus 1. This is plus 1 by square root of 1 plus x square is plus or 1 by square root of x square minus 1. Tan h inverse x is defined as half log 1 plus x by 1 minus x. The derivation of s is 1 by 1 minus x square. This is no square. This is 1 minus x square. That means here 1 by 1 plus x square is tan inverse x. 1 by 1 minus x square is tan h inverse x. Minus 1 by 1 minus x square is cot h inverse x. Minus 1 by or 1 by 1 minus x. Both are same. Minus, if you bring it down, it is also 1 by 1 minus x square. It is also 1 by both are tan h inverse and cot inverse are same. So 1 by 1 minus x square tan h inverse x, 1 by 1 minus x square cot h inverse x. Now let us see the secant h inverse x. Secant h inverse x is minus 1 by square root of x root 1 minus x square. You see, secant inverse is x root x square minus 1. Here, if it is x root 1 minus x square, then it is secant h inverse x. Minus 1 by x root 1 minus x square is cosecant h inverse x. Minus 1 by x root 1 minus x square, 1 minus 1 by x root 1 minus x square. These two are almost same. X is, whenever you write x is less than 1, because 1 minus x square, it should be less than 1, so that we don't get I from here. It also same. So these are the hyperbolic functions. What we are having here is we have derived for sin h inverse x. So we can also derive for other factors also in the same way. But that we should know the relation between sin hx and cos hx. Cos h square x minus sin h square x is 1. Cos h square x minus sin h square x. But in normal trigonometry, cos square theta plus sin square theta is 1. But in hyperbolic, cos square x minus sin square x is 1, because this is how they are defined. Okay. So let us have a quick review. d by dx of sin h inverse x, 1 by square root of 1 plus x square. Just remember, sin inverse is 1 by square root of 1 minus x square, 1 by square root of 1 plus x. Because sin square x plus cos square x is 1, so 1 minus cos square x, 1 minus sin square x. So 1 minus. Here cos square x minus sin square x is 1. So 1 by square root of x square 1 plus x. Here also cos h inverse x plus or minus 1 by square root of x square minus 1. Because see here cos square x minus sin square x is 1. I had to put sin h goes the other side, 1 comes this side. So cos square x minus 1 is equal to sin square x. So sin h is square root of cos square x minus 1. That is square root of x square minus 1. These two relations have come from this equation. Because 1 by sin hy dy dx is cos hy. 1 by cos hy dy dx is 1 by sin hy. So sin inverse is always 1 by dy dx of normal function. So tan inverse 1 by 1 minus x square, cot also 1 by 1 minus x square. So this is how they are defined. H inverse is defined as x plus square root of x square plus 1. Cos h inverse root of log of x plus square root of x square minus 1. Tan h inverse of log 1 plus x by 1 minus x. Cot inverse is half log x plus 1, 1 plus x by x minus 1. Okay. In fact, this is the reverse. X root 1 minus x square, x root 1 minus x. Now, same thing what we are doing, we are just comparing the derivatives here. Sin square x plus cos square x is 1, but cos square x minus sin h square x is 1. Secant square is 1 plus tan square x, but here secant square x plus tan square x is 1. Cosecant square x minus cot square x is 1, but here cosecant square x minus cot h square x is equal to minus 1. So these are the differences. So we know d by dx we have seen. Secant x tan x, secant hx is minus secant hx tan x. So sin inverse x 1 by square root of 1 minus x square. Sin inverse x, sin h inverse is 1 by square root of 1 plus x square. This is 1 by square root of 1 minus x square. This is 1 by square root of 1 plus x square. This is minus 1 by square root of 1 minus x square cos inverse x. This is plus or minus 1 by square root of x square minus 1. This has come from this relation. Tan inverse x 1 by 1 plus x square is equal to 1 by 1 minus x square. Minus 1 by 1 plus x square, cot inverse, this is 1 by 1 minus. These two are same. Secant inverse x is 1 by x root x square minus 1, 1 by x root 1 minus x square. 1 by x root x square minus 1 by x root x square minus 1 is minus 1 by x root 1 minus x square. Both are same. So sin h inverse x is defined like this. Minus x is between minus infinity to plus infinity. Cos inverse x is greater than 1 because this real number, tan and cot. Okay. Now, based on the trigonometric equations, we will do some exercise. Exercise 9.b. Suppose log of secant x plus tan x. So what is the differentiation? 1 by secant x plus tan x into, for secant x it is secant x tan x plus tan x is secant square x. So this get cancelled. Left out is secant x. So what is the integration of secant x? Log of secant x plus tan x. So let us not confuse with integration, just giving an idea. But this is the differentiation of log of secant x plus tan x. Y is log sin log x. So 1 by sin log x into cos log x into 1 by x. See? So similarly, all these things we can do. Let us see 1.15. Sin to the power of mx into cos to the power of nx. So uv. So I put cos to the power of nx, m into sin to the power of m minus 1x into cos x plus. I put sin to the power of x is constant, n into cos to the power of n minus 1x into minus sin x. So when I correct the terms, sin to the power of m minus 1x into cos to the power of n plus 1x. Cos to the power of nx is 1. This is cos x. Cos to the power of n plus 1x. Of course, I have taken out n minus 1x outside. So m cos square x minus n sin square x. So this is the differentiation. Let us see differentiation of 14. Sin x whole square into sin inverse x whole square. So this is a UV formula. So first I put sin inverse x whole square constant. So 2 sin x cos x. So this is sin 2x into sin inverse x whole square plus sin x whole square I keeping constant. This is 2 sin inverse x by square root of 1 minus x square. So this is rearranging the terms. Let us see 1.15. Cos x by cos x plus sin x. This is a UV form. So 1 by cos x plus sin x whole square into cos x plus sin x into minus sin x minus of cos x into minus sin x plus cos x. So when we simplify this term, minus 1 by square brackets 1 plus sin 2x. Okay. So these are all in place of x. Now we are having sin and cos x's. dy dx of sin x plus a by cos x. So 1 by cos square x into cos x plus a minus sin x plus a into minus sin x. This is cos a cos b minus sin a sin b. This is cos a plus b, cos a cos b plus sin a sin b. Cos a minus b, that means cos a. X minus x getting cancelled. Cos of minus a is cos a. So cos a by cos square 2x. This is the answer. Let us see hyperbolic. Sin h square y. 2 sin hy into 1 by 2 sin hy is cos hy. 2 sin hy. Derivative of sin hy is cos hy. It is not sin h inverse. Sin h inverse, then 1 by will come. This is sin h inverse. 2 sin hy cos y dy. So what is given is x is equal to sin h square y. So what is dx? Dx is equal to 2 sin hy cos hy dy. So dy by dx is equal to 1 by 2 hy cos hy. So what is sin hy? Sin hy is root x. And cos hy is 1 by square root of 1 plus sin square x. 1 plus x. So 1 square root of 1 plus sin square y. Sin square y is x. So sin hy is root of x. Cos hy is 1 by square root of 1 plus sin square y. That is 1 by square root of 1 plus x. This is from this relation. This relation. So 1 by 2 square root of, if I take x inside, x into x plus x square. If y is positive, y is negative, x is negative. So this value is between plus or minus 1. Okay. It is written here. So here it is written x plus x square should not be less than 1 under root. No? This cannot be less than 1. And if y is negative, then in the derivation also we'll get another multiplication of minus. Because 2 sin hy cos hy into minus 1 will come if it is minus y. Okay. Anyway. So what is tan h square y divided by dx? 2 tan hy into secant square hy. So tan hy is root x, secant square hy is root of 1 minus x. So this is 1 by 2 root x dx. Tan h is root x. So tan h is root x. So 1 by 2 root x dx is equal to secant square y dy. So secant square is nothing but 1 minus x. 1 minus tan square is secant square. 1 minus tan square tan h square is secant square. See, 1 minus tan square x is secant h square. So this is 1 minus x dy, dey. Dx, this is dx. So dy by dx is equal to, we get the rearranging the terms. My 1 by 2 root x into 1 minus x. Similarly, if dy by dx of x is e to the power of sin h. So e to the power of sin h by into cos h. So let us go to logarithmic way. Let's take logarithms on both sides. Log x to base e is equal to sin h. Excuse me. So 1 by x dx is equal to cos h by dy. dy by dx is 1 by x cos h. So like that we can let us see this one. Log of 1 plus sin square y. X is equal to log of 1 plus sin square y. That means base e. So e to the power of x is equal to 1 plus sin square y. So when I do differentiation on both sides, e to the power of x dx is equal to 2 sin y cos y dy. So dy by dx is equal to e to the power of x by sin 2y. Or there is a second method. X is log of 1 plus sin square y. So dx is equal to 1 by 1 plus sin square y into 2 sin y cos y dy. So if I re-simplify it, I get the same answer. 1 by 1 plus sin square y is 1 by e to the power of x. 1 plus sin square y can be written as e to the power of x into sin 2y. So same answer is coming, whatever method we choose. So this, let us see this. Sin inverse 1 minus x by 1 plus x. Sin inverse 1 minus x by 1 plus x. So what is of sin h inverse x? Differentiation 1 by square root of 1 plus x square. Okay, 1 by square root of 1 plus, this is the whole thing is x. 1 minus x 1 plus x whole square into d by dx of this portion 1 minus x by 1 plus x. So what is the d by dx of 1 minus x by 1 plus x? 1 by u square into 1 plus x into minus 1 minus 1 minus x into 1. So when we simplify, we are getting the answer. So sin h inverse x divided x is 1 by square root of 1 plus x square. We have seen here sin h inverse x derivation is 1 by square root of 1 plus x square. Where is cos h inverse sin inverse x is 1 by square root of 1 minus x. Let us see this one. Sin ax plus b by cos cx plus d. I want derivation. So a by b, u by v, cos square into cos ax plus d into cos ax plus b into a minus sin ax plus b into minus sin a cx plus d into c. So when we rearrange, this is the terms. Let us see here. Sin inverse b plus a sin x by a plus b sin x. So let it be sin inverse x is 1 by square root of 1 minus x square. Let it be 1 by square root of 1 minus u square du by dx, where u is this portion. Okay. Now 1 by square root of 1 minus u square. 1 by square root of 1 minus u square is b plus a sin x by a plus b sin x. So 1 minus x square, this x square is brought here. LCM has been done. This x is brought to top. A plus b sin x by square root of a plus b sin x whole square minus b plus a sin x whole square into du by dx. So we are simple. This when we simplified it, this becomes a square minus b square plus sin square x into b square minus a square. So this is one equation. Let us see du by dx. Du by dx is equal to 1 by a plus b sin x whole square into a plus b sin x into a cos x minus b plus a sin x into b cos x. So this is the, when we simplify this, when we do du by dx into this and simplify, what we are getting? Square root of a square minus b square by a plus b sin x. So this has been done in two steps. One is assuming this as u. Sin inverse u is 1 minus square root of 1 minus u square. So this has been simplified. And du by dx is separately done. U by v. So when we multiply these two and cancel out the terms, cos x into a square root b square, cos x into a square is getting cancelled. So what is left out is a square root of a square b square by a plus b sin x. Okay. Let us continue differentiation, and we learn some different methods to do differentiation to make our work easier. Some different ways of methods like substitution method, logarithmic method, parametric method. We'll see that. Okay. So in the different methods of subdifferentiation. Substitution method. Suppose if it is given example tan inverse root of 1 minus x by 1 plus x. So if you put x as cos theta, so 1 minus cos theta by 1 plus cos theta, that is equal to tan square theta by 2. Let x is equal to cos t. Then 1 minus cos t by 1 plus cos t is tan square t by 2. So when the root is going out, we get tan t by 2. So this is tan inverse tan t by 2. Tan inverse tan t by 2. Tan t by 2. That is t by 2. Tan inverse tan theta is theta itself. T by 2. T by 2, we have to do dy by dx. Dy by dx is equal to half into dt by dx. What is dt by dx? X is cos t. So dt by dx is minus sin t. Minus 1 by sin t. Sin t is 1 root of 1 minus x square. So what we have done here, y is tan inverse root of 1 minus x by 1 plus x. We have to differentiate. Otherwise, how we have to do? Dy by dx is tan inverse theta. So 1 by 1 plus x square into dy by dx of this. Into dy by dx of this. So this is a very long process. 1 by 1 plus x square into the dy by dx of u by v method. So in place of that, we are putting so we know tan t 1 minus cos t by 1 plus cos t is equal to what is 1 minus cos t? You can say 2 sin square t by 2. This is 2 cos square t by 2. 2 getting cancelled. Sin square t by 2 by cos square t by 2 is tan t by 2. So cos t can be written as 1 minus 2 sin square t by 2. So 1 getting cancelled, minus into minus plus. So 2 sin square t by 2. This is 2 cos square t by 2 minus 1 plus 1 minus 1 getting cancelled. 2 cos square t by 2. So like that, the substitution method is easy. Let us see here. Tan inverse 2x by 1. We know 2 tan theta by 1 minus tan square theta is equal to tan 2 theta. So x is equal to tan theta. So this becomes 2 tan theta by 1 minus tan square theta is tan 2 theta. So that means tan inverse tan 2 theta is 2 theta itself. 2t itself. So dy by dx is 2 into dt by dx. dt by dx is what? 1 by 1 plus x square. Secant square t dt 1 by 1 plus x square. Tan t is x. Secant square t is 1 plus x square. So dt by dx comes this side, tan t goes other side. Okay. What is dx here? Secant square t dt. So dt by dx is 1 by secant square t. That means 1 by 1 plus x square. So this is one method. What is the second method? Logarithmic method. Wherever powers are there, let us go for logarithmic method. Suppose y is x to the power of x. So what is log y? Log y is x log x. Now you differentiate 1 by y dy is equal to x into 1 by x plus log x into 1. So 1 plus log x dx. So dy by dx is 1 plus log x into y. Y is x to the power of x. X to the power of x into 1 plus log x. Okay, this is logarithmic differentiation. Let us see parametric differentiation. Parametric means both converting them into a common variator. X is in the form of t, y is in the form of t. So dx by dt, dy by dt. When I divide dy by dt by dx by dt, I'll get dy by dx. So dx by dt is 3a cos square t into sin t. See, what is y is a sin cubed t. What is dy? 3a sin square t cos t. 3a sin square t cos t. Here what is dx by dt? 3a cos square t into minus sin t. So total is minus tan. So dy by dx is tan minus tan t. For implicit function, implicit means what? We have same powers. This is degree 2, this is also degree 2, this is also degree 2. Y to the power of 1, x to the power of 1, total together degree 2. So if it's the same type of implicit functions, we will directly differentiate. So let us see the example. This is it. X cubed plus y cubed minus 3a xy. So x cubed I am differentiating 3x square dx, y cubed differentiating 3y square dy, minus 3a x into dy minus 3a y into dx. So combining all dy terms together, dx terms together, and bringing the del J. Suppose you see here. So based on these three, we have some examples here. Y is tan inverse root of 1 plus x square plus root of 1 minus x square by square root of 1 plus x square minus square root of 1 minus x. So here let x square is equal to substitute as cos 2a. So tan inverse 1 plus x square. So 1 plus cos 2a. See, 1 plus cos 2a. X square is cos 2a. So this becomes 1 plus cos 2a. So 2 cos squared x minus 1, 2 cos squared a minus 1, 1 getting cancelled, 2 cos squared a. Under root means cos a root 2. Cos a root 2. Root 2 will come. Here also 1 minus x square, 1 minus cos 2a. This is 1 minus 2 sin squared a. So root 2 sin a. 1 minus 2 sin square a plus 2 sin square a. So root 2 sin a. So root 2 top and bottom getting cancelled. It becoming cos a plus sin a by cos a minus sin a. Tan inverse. This is nothing but 1 minus tan a by 1 plus tan a. Because I am dividing by cos a everywhere. So 1 plus tan a by 1 minus tan a. This is nothing. If 1 is tan 45, tan a minus plus tan a by 1 minus tan a tan. This is wrongly. This is 1 plus tan a by 1 minus tan a. So tan inverse tan of 45 plus a. Tan a plus tan b by 1 minus tan a tan b. So this total tan inverse whole thing is becoming just 5 by 4 plus a. So now dy by dx is dy by dA into dA by dx. So this becomes 0. So 1 into dA by dx. What is a we got as cos 2a is x square. So 2x dx is equal to sin 2a minus sin 2a into 2. So sin 2a converting into from cos 2a, if you take out sin 2a, it is 1 minus x square. So raise root of 1 minus x to the power of 4 minus x by square root of 1 minus x to the power of 4. This is an example. Let us do exercise 9C based on different methods. Y is equal to x to the power of tan x plus, this is also one of the example. Then this is the exercise portion. Let us see. X to the power of tan x plus sin x to the power of cos x. Find dy by dx. So here f of x plus g of x. I can do differentiation separately. So y is y1 plus y2. So now I want to find out dy1 by dx plus dy2 by dx. So y1 is the x to the power of tan x. Let it take logarithm on both sides. Log y1 is equal to log tan x. Log x. Log y1 is equal to tan x log x. Now you differentiate 1 by y1 into dy1. y1 dash by y1 is equal to tan x by x plus log x into secant square x. Tan x into 1 by x, differentiation of log x plus log x into secant square x is equal to 1 by y1 into y1 dash. So we will get y1 dash. Similarly, we will get y2 dash. So y1 dash plus y2 dash is my dy by dx. Okay. So whenever we have to identify separate functions, means we have to do separately. Let us exercise 9 points. dy by dx of sine inverse 3x minus 4x cubed. We know 3 sine theta minus 4 sine cubed theta is sine 3 theta. So I put x as sine theta. So this is 3a. Answer is 3a. So dy by dx is 3 into dA by dx. What is dA by dx? Is cos a dA is equal to dx. So dA by dx is 1 by cos a. So 1 minus square root of 1 minus x square. Simple. Now, or we can do this also. 1 by square root of 1 minus x square into 3 minus 12x square. So sine inverse x is 1 by square root of 1 minus x square into differentiation of this is 3 minus 12x square. If I do it, I will get same answer. But here we see substitution method is easier method. Okay, let us see. Sine inverse 2x by 1 plus x. We know 2 tan theta by 1 plus tan square theta is equal to sine 2 theta. So 2 sine 2 theta, so it becomes 2a. So we put x is tan theta. So 2a 2 by secant square theta is 1 plus x square. So by seeing itself, we should be able to tell in what terms of sine I will get this. 2 tan theta by 1 plus tan square theta is sine 2 theta. 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. So we have to use our trigonometric identities. Now let us see this. Tan inverse square root of 1 minus x by 1 plus cos x. Same. One minus cos x by 1 plus cos x. This is 1 minus 2 sin squared x by 2. This is 2 cos squared x by 2. So total become tan squared x by 2. This is x by 2. Simple directly, it is x by 2. So it is r minus x by 2. So where tan x by 2 is positive, 0 to 180 degree, x by 2 is between 0 to 90 degree. That means positive. Between 0 to minus 180, x by 2 between 0 to minus 90, where it is negative. So dy by dx is half or minus half, plus or minus half. Okay. See, tan theta is positive in first and third quadrant, but x by 2 is between 0 to 90. 0 to 180 means x by 2 becomes 0 to 90 positive. This is negative. Okay. Now, secant square inverse 1 by 2x square minus 1. Let x is equal to cos theta. Okay. 2 cos square theta minus 1 is cos 2 theta. It comes to top, it becomes secant 2 theta. So this is 2 theta. Secant inverse secant 2 theta is 2a. So dx is 2 by minus sin A. That is, this is the answer. Let us see 1.2.3. Tan inverse 2x by 1 minus x. Same thing. 2 tan, we have just done this. 2t by 1 minus 2 tan theta by sin theta. 2 tan theta 1 minus tan square theta. Y1 is given, Y2 is given. We have been asked dy1 by dy2. So dy1 by dx, dy2 by dx, I can differentiate, I can do substitute. So dy1 by dx is equal to tan inverse tan 2a, where x is equal to tan a. This is tan inverse tan 2a, that is 2a. This is a dy1 by dy2. Here sin inverse 2 tan t by 1 plus tan square t is sin 2t sin 2a. So this is also 2dA. So dy1 by dy2 is equal to 2 by 2, that is 1. And both are same. Okay. Let us see this. Tan inverse this, we want dy by dx. Tan inverse, I'm taking x out here. X into 3a square minus x square by a into a square minus 3x square. What is tan 3 theta? Tan 3 theta is equal to 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. See, I have written here a because writing theta is difficult for me. That is why you can put 3 tan a minus tan cube a by 1 minus 3 tan square a. But in terms of theta also, we can read this. Okay. So we convert this into tan 3 theta. At x is equal to a tan a. That means x by a is equal to tan a. X by a is dx is equal to a secant square a dA. dA by dx is 1 by a secant square a. 1 by a into 1 plus x square by a square. Secant square a means 1 plus x square by a square. So a by a square plus x square. So now y is tan inverse 3a cubed 3a cubed tan a, because x I am taking as a tan a. A tan a. So 3a cubed tan a minus a cubed tan cubed a by a cubed minus 3a cubed tan square a. I am taking out a cubed, getting cancelled. So I am getting rest is my tan 3a, that is 3a. So 3 into dA by dx is 3 into a by a square plus x square. So what we have to learn here is how to convert this into a tan function. So this is 3 tan a minus tan cubed a by 1 minus 3 tan square a is tan 3a. Okay, let us see this. Tan inverse root of 1 plus x square minus 1 by x. Let x is equal to tan a. So root of 1 plus tan square is secant square a. That is cos a. This is 1 a. This is secant a minus 1 by tan a. This portion is secant a minus 1 by tan a. That is 1 minus cos a by sin a. And minus cos a by sin a means tan a by 2. So this whole function becoming a by 2. So dA by 2. So dA by 2 we can get from this. dA by dx we can get from this equation. Okay, we should see how to convert this. So x is equal, mostly these are all x is equal to tan a. You see, this is also a tan a. This is tan a. Here also we have seen somewhere 2 tan theta by 1 minus tan square theta. Here also tan. Here also tan. So mostly because sin theta, cos theta, tan theta are defined in tan theta. Let us see this. Which one? 2.1.6. 20 to the power of log tan x. Try to differentiate. So take logarithm on both sides. Log y is equal to log tan x into log 20, because log 20 to the power of log tan x. So log tan x comes to the side, log tan x into log 20. Now we have two terms uv. So 1 by y divided by dx is equal to 1 by log 20 into 1 by tan x into secant square x. Log 20 so log 20 is only a constant term. So log 20 is a constant term. So now I have log tan x, I have to differentiate 1 by tan x into secant square x. So then we can simplify the equation. Okay. Let us see 2.2. X is equal to 380 by 1 plus t cube. Y is equal to 380 square by 1 plus t cube. Find dy by dx. So dy by dx, this is y, this is x. 380 by 1 plus t cube. 3a t square by 1 plus t cube. So x into t is y. Y is equal to x into t. So dy by dx is equal to dx into t plus x into dt. So dy by dx is equal to t plus x into dt by dx. So dy by dx is equal to t plus, this is dt by dx. X is what? X is 380 by 1 plus t cube into dt by dx. This is dt by dx. I can calculate from here dt by dx. 1 plus t cube whole square by 3a minus 6a t cube. See, what is dt by dx? If you see here, x is equal to this. So dx is equal to 380 by 1 plus t cubed differentiation. So u by v, 1 plus t cubed whole square, 1 by 1 plus t cubed whole square into 1 plus t cubed into 3a minus 380 into 3t square. 380 into 3t square. So if dt by dx, this comes here, this whole thing goes to the other side. So that is what is 1 plus t cubed whole square by 3a minus 6a t cubed. When we simplify this, t plus this, we are getting a answer. We can do otherwise also. First we do dy by dt, then dx by dt, then divide. So what is dy by dt? Dy by dt is 1 by 1 plus t cubed whole square into 1 plus t cubed into 6a minus 3a square into 3t square. 3t minus 3a t square into 3t square. So this is 9a t to the power of 4. Similarly, dx by dt. This is 9a t to the power of 4. We have 3 into 3, 9. 1 by 1 plus t cubed whole square. What is y? Y is given here. 1 by 1 plus t cubed whole square into 680. 1 plus t cubed into 680. 1 plus t cubed into 680 minus 3a square into 3t square. The 3's are 9a t to the power of 4. Okay. Similarly, dx by dt. We have just seen dx by dt here. 1 plus t cubed, 1 by 1 plus t cubed whole square into 1 plus t cubed into 3a minus 3at into 3t square. Here also 9. So when we divide dy by dx, I'm getting this answer. So both way we can do it, but it is easy to have dy by dt and dx by dt. Let us see this one. X is equal to a into 1 minus t square by 1 plus t square. Y is equal to 2bt by 1 plus t square. Here it is simple. This is 1 minus t square by 1 plus t square. It is getting my sine 2t. This is 2t by 1 plus t square tan 2t. Let us see. Let t is equal to tan a. So x is equal to a cos 2a. Y is equal to b sin 2a. This is 2t by 1 plus t square is sin 2a. 1 minus t square by 1 plus t square is cos 2. 1 minus tan square theta by 1 plus tan square theta is cos 2a. 2 tan theta by 1 plus tan square theta is sin 2a. So we have converted them into the substitution method. So we know dx by dy by dx is equal to, so here dy dA, b cos 2a into 2 by a sin minus sin 2a into 2. So this is cot 2a. So minus b by a into, what is cot 2a? 2t by 1 minus t square. Normally this is tan 2a, but cot 2a is cos 2a by sin 2a. So cos 2a is 1 minus 2t square, 1 minus t square by 1 plus t square. So cot 2a is 1 minus t square by 2t, because cos 2a by sin 2a. Let f of x is log x to base a. This is base a. G of x is a to the power of x. What is d of f of x by d of g of x? So df of f of x is 1 by x into log a, log x to base a. This is log x to base a. So d by dx is 1 by x into log. So 1 by log x to base a. This is 1 by x into log a. Differentiation of this is 1 by x into log a. What is differentiation of this? A to the power of x log a. A to the power of x log a. So this differentiation divided by this differentiation, both with respect to x, is given to d of fx by d of gx. So when we simplify, we get this. Let us see. Y is equal to log x. How we got log x to base a? Let y is equal to log x. That means base a. So a to the power of y is equal to x. A to the power of y is equal to x. That means if I take both sides logarithmic, y log a is equal to log x. When I differentiate, log a dy is equal to 1 by x dx. Log a dy is 1 by x dx. So dy by dx is equal to 1 by x log a. That's what I have applied here. Okay, this is how we got it. How we will do like this when separate base is given? Log x to base a, let us put as y. So a to the power of y is equal to x. Then we do logarithmic on both sides and we will get dy by, so df by dx. So differentiation of log x to base a is 1 by x log a. Now tan inverse root of 1 plus x square by x, gx is tan inverse x. Okay, we have to, so first dfx by dx. Let x is equal to tan theta. So 1 plus tan square is secant square theta minus secant theta minus 1. Earlier we have done this. This is tan a by 2. So this becomes tan inverse tan a by 2, a by 2. So dy by dx is 1 by 2 into 1 plus x square. This is also 1 by 1 plus x square. Tan inverse x is 1 by 1 plus x square. Differentiation of tan inverse, they get cancelled. Answer is half. Now, let us see 5.2. X root a square plus x square plus a square log of x root a square plus x square. We want dy by dx. So a y1 plus y2. So x root a square plus x square. This is x into 1 by 2 root a square plus x square. So this is u, this is v. So I'm putting u constant. 1 by root of a square plus square is 1 by 2 root a square plus x square into 2x plus v constant into dx plus a square. This is log 1 by x plus square root of a square plus square into 1 plus again x by square root of a square plus x square. Because 1 by 2 root of a square plus square into 2x. 2 getting cancelled, x by square root of x. So when I simplify, I get the answer as 2 root a square plus x square. Now, y is tan inverse 2x by 1 minus x square plus tan inverse 3x minus x cubed by 1 minus 3x square minus tan inverse 4x minus x of x cubed by 1 minus 6x square. So this is the problem. So let us say y is equal to y1 plus y2 plus y3. These are all plus. This is plus. This is a minus. Okay, y1 plus y2 plus y3. Let us say what is y1? y1 is tan inverse 2x by 1 minus. We know 2 tan theta by 1 minus tan square theta is tan 2 theta. So tan inverse tan 2 theta, that is 2 by 1 plus x square. So y1 we got. y2. This is 3 tan theta minus tan cube theta by 1 minus 3 tan square theta is tan 3 theta. Tan 3 theta. So 3 by 1 plus x square. What is y3? This is tan 4 theta. Tan 4 theta. Because tan 4 theta is tan 2 theta plus 2 theta. Tan A plus tan B by 1 minus tan A tan B. That is equal to tan 4A. We are getting 4x. If tan A we treat it as x, we get 4x into 1 minus x square by 1 minus 6x square plus x to the power of 4. This is what is given here. So this total figure is tan 4a. So minus 4 by 1 plus x square. So this is minus here. So when we do the all the y1 plus y2 plus y3, we get the answer. So dy by dx is equal to 1 by 1 plus x square. This is 2 by 1 plus x square. This is 3 by 1 plus x square, total 5 by 1 plus x square, minus 4 by 1 plus x square. So balance is 1 by 1 plus x square. This is how tan 4a has been arrived at. 4 tan theta into 1 minus tan square. 4 tan theta minus tan cubed, 4 tan cubed theta. 4 tan theta minus tan cubed theta. By 1 minus 6 tan square theta plus tan to the power of 4 theta. Okay. So let us do some more problems on differentiation, and we'll also see double differentiation. Double f dash x, f double dash x. That also we will learn. Let us see. Earlier we have done up to tan 4a. This problem. Now we are continuing. If x to the power of y is equal to y to the power of x, find dy by dx. All such things, wherever power of is there for y or x, we will use logarithmic method. So if I take log on both sides, y log x is equal to x log y. So I can differentiate log x plus y by x. This is log x into dy plus y by x into dx. Similarly here, log y dx plus x into 1 by y dy. So I bring together all dy and dx's, and dy by dx can be formed. Okay, let us see. Y is given sum x to the power of 2 by 3, x2 to the power of 3 by minus 3 by 4 divided by x3 to the power of 5 by 6 divided by x4 to the power of minus. So such products are there. It is almost like A into B by C into D. AB by CD. So we can do in X U by V formula also. It will be very large. So we'll use logarithmic method. So log Y is equal to log AB by CD. Entire log AB by CD means log A plus log B minus log C minus log D. So these all multiplications and divisions are separated individually. Now it is easy for us to differentiate. 2 by 3 into 1 by 1 minus 2x. So log y is 1 by y dy. So 1 by y is coming on the other side. So dy by dx is equal to y into minus 4 by 3 into 1 minus 2x to the power of minus 9 by 4 into 1 plus 3x. So how we got it? So minus 3 by 4 is there. 2 by 3 is there. 2 by 3 log 1 minus 2x is 1 by 1 minus 2x. 1 by 1 minus 2x into minus 2. So minus 2 into 2 minus 4. Minus 4 by 3 1 minus 2. This is in the denominator. Similarly here 1 by 1 plus 3x into 3. So minus 3 into 3 is 9. So minus 9 by 4 1 plus 3x. This is 1 by 1 minus 6 into minus 6. Minus into minus 5 plus 6 getting cancelled. So plus 5 by 1 minus 6. Similarly here 1 by 1 so 1 plus 7x into 7. 7 getting cancelled. 6 by 1 plus 7. So it is my work made easier by using logarithmic method. Similarly here a square b cubed by c cubed. Again simple logarithmic approach. Let us see here. Y is equal to sine to the power of x log x plus x to the power of sine x. So here, if I take directly y log of a plus b, log of a plus b, it cannot be split into. Log of ab can be split as log a plus log b, but log of a plus b cannot be split. So we have to do it in a different way. This is y1, this is y2. Split it into two functions, y1, y2. So y dash is equal to y1 dash plus y2 dash. Now in y1, if I take log y1, so log x log sin x. So it is easy for me to differentiate 1 by y1 divided by dy1 by dx is equal to 1 by x into log sin x plus log x into 1 by sin x into minus into cos x. Similarly, y2 dash I will get, so I can add both. Similarly, see here. Similarly, here also same. I cannot straight away take log here. I have to take it as y1, take it as y2. So y1 dash x and y2 dash. I can take log after y1 is x to the power of x, log y1 is x log x. So 1 by y1 divided by dx is x into 1 by x is 1 plus log x. So y1 into 1 plus log x. Similarly, y2 is x log cot x. It is y2 is x log cot x. So derivative is y2 into x into 1 by cot x into minus cosecant squared x plus log cot x into dx. So this dy by dx can be both dy1 plus dy2 by dx. Next thing, x to the power of y plus y to the power of x is equal to a to the power of b. This is a constant. A to the power of b means what? It is a constant. Again, same y1 plus y2 is constant. When I do differentiation, y1 dash plus y2 dash is 0. So I have to find out individual y1 and y2 dash. I can. So y1 dash is equal to y1 into y log x. So y by x. This is x to the power of y. So y log x. So y by x plus log x into dy by dx. Similarly, y2 dash is x by y plus dy by dx into plus log y. So we have to rearrange the terms dy by dx and bring the numerator and denominator. Let us say this one, 2.2. Sine inverse root of a by b. Gx is tan inverse root of a by some a minus x. So we want to say, prove that f dash x and g dash x are same. So f dash x, sine inverse x, 1 by 1 minus x square into, what is the differentiation of root of a by b? So 1 by root of a minus b is what? It is a constant term. This is not containing x. So 1 by root of a minus b into root of x minus b is 1 by 2 root x minus b. 1 by 2 root x minus b. So this is f dash x. Similarly, g dash x, tan inverse. So 1 by 1 plus x square. Tan inverse means 1 by 1 plus x square means root will go into, this is a minus x. This is x minus b. So 1 by a minus x into 1 by 2 root x minus b. This is whole square. This is 1 by a minus x whole square into root of a minus x into 1 by 2 root x minus b minus root of x minus b into what is differentiation of root of a minus x? 1 by 2 root a minus x into minus 1. So u by v formula is applied and we have simplified this and we are getting same as f dash x. Same as, because a by a minus b getting we are getting same as this a minus x into x minus. Another problem, 3.2.3. If x square is this, whole to the power of minus half means 1 by root. Minus half means what? 1 by root of a square minus b square. A square and b square is a constant. So this constant will remain same. So cos inverse this. What is cos inverse? Minus 1 by square root of 1 minus x. Minus 1 by square root of 1 minus x square. Into what is the dy dx of this portion? Is 1 by a plus b cos x whole square into a plus b cos x into minus a sin x minus differentiation of this is minus a sin x. Similarly, minus a cos x plus b into what is the differentiation of this? Minus b sin x. So when we rearrange the terms, we are getting all the terms getting cancelled. This is 1 by a plus b cos x. Here we are getting a plus b cos x whole square. So square getting cancelled. So left out term is 1 by a plus b cos x. Okay. Let us see double differentiation, second order derivatives. F dash x we know, f of x plus h minus f of x by h. This is dy, this is dx, as dx tends to 0. This is the first order. So second order we will use with f dash. F dash x plus h minus f dash x by h as h tends to. Means the slope of the slope. What is this called? Slope of the slope. So similarly, f to the power of n is equal to f dash to the power of n minus 1 x plus h minus f dash of n minus 1 x by h as h tends to 0. So normally second order, third order we use in engineering solution. For a simple thing, suppose the f of x is a displacement, then f dash x is velocity because dx by dt. Then f double dash x is acceleration, d velocity by dt. So like that, that second acceleration is there. So sometimes we have to use third also for other engineering applications. So let us see example. Sin a, sin 2a, sin x, sin 2x, sin 3x. Find f double dash x. So we know sin a, sin b, sin c. So I am putting sin 2x aside. So sin a, sin b. Sin a, sin b can be written as half into cos a minus b minus cos a plus. So cos a minus b x minus 3x is minus 2x. 2x means 2x. Cos of minus theta is cos theta. So a plus b is 4x. So half into cos a minus b minus a minus b minus a plus b, because it is actually minus sin a sin b. It is actually minus sin a sin b. Minus 2 sin a sin b. We know cos a plus b minus cos a minus cos b is equal to minus 2 sin a plus b by 2 sin a minus b by 2. Same thing is reverse. Let us see here. I am writing here cos A minus cos B is equal to minus 2 sin A plus B by 2 into sin A minus B by 2. So this is the thing. Now it is given sin A, sin B, sin X, sin 3X, sin X, sin 3X. So X can be written as 3X minus X, and this is 3X plus X. So this is sin cos 2X and cos 4X. So cos A minus cos B. So A plus B by 2 is equal to X is equal to 3X. A minus B by 2 is equal to X. So we find out cos 2X minus cos 4X. So half is there because this 2 comes here, this becomes half. So here it is no more cos of A plus B by 2 minus cos of A minus B by 2. That B by 2, A plus B by 2 will not come because that is on this other side. So A plus B by 2 is X is 3X. So A plus B is 6X. A minus B is 2X, from which A is 2X and B is 4X. Okay, right, because minus is taken inside. So now we had separated. Now again we got sin 2x cos 2x. You know, 2 sin A cos A is sin 2A. We got this in one single term. Sin A cos B, sin A cos B. This can be written as sin A plus B minus sin A minus B. What is sin A cos B? Sin A plus B plus sin A minus B is sin A cos B. So we should have a very thorough knowledge of these conversions. Okay, sin A cos B. Cos A sin B is sin A minus sin B. Sin A cos B, cos sin A plus sin B. So sin of A plus B, 2x plus 4 is 6x plus sin of A minus B minus 2x. So we got simple sign terms. Now we know f dash is 1 by 4 into cos 2x into 2, cos 4x into 4 minus cos 6x into 6. Now what is f double dash x? 1 by 4 into minus sin 2x into minus 2. Minus 2 into 2 minus 4 sin 2x. Minus sin 4x into 4 minus 16 sin 4x plus 36 sin 6x. So when we have simplified it, we got the answer. So what is that we have to learn in this exercise? We should have a thorough conversions of all these changes. Okay, cos A minus cos B. Let us see here. Right here. Sin A plus sin B is equal to 2 sin A plus B by 2 into cos A minus B by 2. Similarly, sin A minus sin B. So sin A minus sin B. 2 cos A plus B by 2 into sin A minus B by 2. Sin A minus B by 2. Now again cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. What is cos A minus cos B? Equal to minus 2 sin A plus B by 2 into sin A minus B by 2. So we should be able to, whenever in differentiation, if we get the product, we should be able to convert into separate, so that I can do differentiation of sin x, I can do differentiation of sin. Here also I can do. How I can do? UV in a process of UV. Let us see in a UV way. Can we do it UV way? UVZ. So I can do it sin x, sin 2x into this is cos 3 cos 3x. Sin x, sin 2x into 3 cos 3x plus sin 2x, sin 3x into cos x plus sin x, sin 3x into cos 2 cos 2x. So this is my f dash x. Similarly, f dash dash also can be done. So both ways we can do it. I think that is more easier. Okay, let us go. X is given in terms of t, y is given in terms of t. Find d square by dx square. So now we know dy by dt, dx by dt, then I get dy by dx. So dy by dx is equal to dy by dt. So a minus a sin t minus a sin t divided by what is this? A into 1 minus cos t. A into 1 minus cos t. So this is dy by dt dx. So d square by dx square is now again 1 cos t minus 1 whole square into 1 cos t minus 1 into cos t minus sin t into minus sin t. So I am getting d square by dx square. The total, when I simplify this, or I can do otherwise also. I can do d square x by dt square, d square x by dt square, d square y by dt square. Then also I can do it. Both way can be done. Now, y is given y double dash. So we know y dash u by v, 1 by v square, v into u dash minus u into v dash. So y double dash also again minus 2 into 4x plus 5 whole to the power minus 3 into 4. I got the answer. Now, let us see this problem. Y is equal to a e to the power of nx plus b e to the power of minus nx. So y dash is easy. Y dash is equal to a n e to the power of nx. So he has done taken log, but we can e to the power of nx. A n e to the power of nx. Similarly, this is minus b n e to the power of minus nx. Y2 dash is minus n y2, y1 dash is n y1. Simple. Okay. Now y double dash is again we have to re n into a e to the power of nx minus b e to the power of minus nx. So y double dash is n into again n into a e to the power of nx plus b e to the power of minus nx. This is nothing but y. So n square y. This is n square y. So y dash is n into, because minus has come. The given expression is plus. So here minus, so this is not total y. But when you do re-differentiation, this minus n will come here. This becomes plus. So n square y. Let us say cos cubed x is y. So y dash is 3 cos x into minus sin x. So y double dash is, I can do it UV formula, minus 3 into, this is cos x into cos square is cos cubed x plus sin x into 2 cos x minus sin x. So I have to simplify it. This is only for explanation. Now let us see another. Y is equal to e to the power minus 2x sin cubed x. So y dash is e to the power minus 2x into 3 sin square x into cos x plus sin cubed x into e to the power minus 2x into minus 2. So this plus become minus. Then again we can do double differentiation. Again this is what? This is 3. So e to the power minus 2x into 6 sin x into cos square x or 3 sin square x into minus sin x plus 6 sin x cos x, because 3 2s are 6 sin x into cos square x, cos x into cos x, cos square x, plus 3 sin square x cos x into e to the power minus 2x into minus 2. So it's simple UVZ differentiation. We have to arrange the terms. So tan inverse, I want double dash. So what is tan inverse? Let us assume x as, this is tan 45 plus tan A by tan 45 minus tan A. So this is tan 45 plus A. So this is A. So y dash is secant square A. Secant square y dash is 1 by secant square. That is 1 by 1 plus x square. Here because x is, I assumed x as tan A. So this I have to do double. So 1 plus, minus 1 by 1 plus x square whole square into 2x. So let us see this problem. Y is given y1 plus y2. So we have to put y double dash 6y dash 9y. We have to prove this. So first let us write what is 9y. So this is 9y. And what is y dash? Y dash is 6 plus a 3a into e to the power of 3x e to the power of 3x into differentiation of this is b plus 3 into a plus bx into e to the power of 3x. So this is differentiation. So this is y dash. So I want 6y dash. 6. This is 6y dash. What is y double dash? This is 0. This is 3b e to the power of 3x. 3b e to the power of 3x plus 3 into a plus bx into 3. 9 into a plus bx into e to the power of 3x plus 3 e to the power of 3x into b. So this is y double dash. When I apply in this equation, I am getting 5x 44x plus 18. So we have to individually put and add as per this. Similarly, this y is given. So y dash. So 128 will keep it separate. 3 sin square x cos to the power of 5x minus, because cos x is minus sin x. 4 cos cubed x into sin to the power of 4x. Again y double dash uv, uv and uv. Get 4 expansive terms. Okay. Let us see this one. A e to the power of minus kt cos pt plus c. We have to prove that this equation. So let us put first y dash. Y dash is equal to a minus ak e to the power of minus kt minus ak e to the power of minus kt cos pt plus c plus a e to the power of minus kt into minus sin pt plus c into p. So this is y dash. What is double y dash? Y double dash. Again I have to do this 2 times. A k square into e to the power of minus kt cos pt plus c plus a p sin pt plus c. Similarly, this term also 2 times is uv formula we have applied. So we got d square y by dx square. So this is nothing but k square minus p square a e to the power of kt cos pt plus c. A e to the power of minus kt cos pt is y itself. So this portion is y plus 2k into what is this portion? A p e to the power of minus kt. This is where AP e to the power of minus kt sin pt plus c. This is AP k e to the power of minus kt sin pt plus c. This is nothing but this is AP e to the power of minus kt sin pt plus c is equal to minus ky. This is k minus ky. This is also coming here minus dy by dt. This is going to the other side. So against this, I am putting minus ky minus dy by dt. So when I simplify, I am getting the required answer. So it is always better to put in terms of y and y dash. You can put in terms of y and y dash, y double dash, because somewhere will cos and sine they get reappear. Okay. You see here. Suppose in our x is equal to a sine omega t. This is our simple harmonic motion. When I differentiate dx by dt is equal to a omega cos omega t. When I double differentiate it is d square x by dt square is equal to a omega square minus sine omega t. So that is equal to minus a omega square, you remove a. So minus omega square into x. Because a sine omega t is x. So we can rewrite in terms of x minus omega square x. This is d square by dx square. Okay. So that is equal to d square by dx square is acceleration. So d square is acceleration is equal to minus omega square into displacement. So we use this x. Similarly, this y can be used here. Similarly, this dy by dt also can be used in y double dash wherever possible. So we should have that approach. So with this, our differentiation lesson is over. We have to do more and more practice so that we can have full control over the differentiation.